Practice this with an example. Evaluate the indefinite integral 1 over x squared square root 25 minus x squared dx. Alright. Now, the basic quantity you look here is this square root 25 minus x squared. What form is it? It is of the form square root a squared minus u squared. So what is your a? What is your u? Those are the things you must think about. So we have the expression square root 25 minus x squared on the denominator. And this is of the form, undoubtedly, of the form a squared minus u squared on the square root. With your a squared equal to 25, therefore a equal to 5, u squared equal to x squared, therefore u equal to x. Now, therefore, what is our substitution? Our substitution must be u equal to a sine theta, but in our case, u equal to x. So we say x equal to 5 sine theta, u equal to a sine theta. In this case, u equal to x and a equal to 5. So we substitute x equal to 5 sine theta. Now remember, when you make a substitution of one quantity, every other x must follow this substitution. That means we need to replace the dx. We also need to replace that x squared. So, what is dx equal to? If x equal to 5 sine theta, dx equal to 5 cos theta d theta, and x squared is 25 sine squared theta. That means when you replace this 25 minus x squared as, well, we will replace x as 5 sine theta. When this x is replaced as 5 sine theta, this dx need to be replaced by 5 cos theta d theta, and this x squared need to be replaced by 25 sine squared theta. Let's do that. So this integral now become integral x squared is replaced by 25 sine squared theta. The x squared inside the square root is replaced by 25 sine squared theta, and dx is replaced by 5 cos theta d theta. We first start by simplifying inside the radical sign. We factor out a 25, so that will be, everything else remain the same. We deal with this. We factor out a 25. That will be square root 25 times 1 minus sine squared theta. Now look at the desired form that we created here. What is 1 minus sine squared theta? Is cos squared theta. So this 1 minus sine squared theta will be now replaced by cos squared theta. And the quantity inside the square root now is 25 cos squared theta. Okay, now 25 cos squared theta under square root now becomes square root 25 is 5, square root cos squared theta is cos theta. So we are going to remove that square root sign, and now we have integral, look at that, d theta is 5 cos, the dx has been replaced by 5 cos theta d theta. So that would be 5 cos theta d theta divided by 25 sine squared theta, and this quantity in the square root is now 5 cos theta. And if you notice, the 5 cos theta and the 5 cos theta will cancel. What do we have? We have integral 1 over 25, we take that 25 outside, 1 over 25, 1 over sine squared theta d theta. Alright, and what is 1 over sine squared theta? 1 over sine squared theta is cosecant squared theta. Now, can you integrate cosecant squared theta d theta? Yes, the derivative of cot theta with respect to theta is negative cosecant squared theta. Therefore, integral of cosecant squared theta d theta must be, yes, negative cot theta. So, that is 1 over 25, integral cosecant squared theta d theta is negative cot theta plus c. Those basic integration forms you must be very familiar with. Well, now we have been asked to integrate a function of x, and we have obtained the result as a function of theta. That is not acceptable. That means we need to now go back and replace theta in terms of x. How do we do that? We've got to go back to our substitution. Now we use the original substitution to write the answer in terms of x. Our answer needs to be in terms of x. So what is the original substitution? X equal to 5 sine theta. Now can you visualize a triangle where theta is an acute angle and sine theta equal to x divided by 5? There you go. Sine theta equal to x divided by 5. So what we do is we draw a right triangle with theta as an acute angle and decide on the sides of the triangle using this substitution. So this is our triangle and this is our angle theta, the acute angle. Sine theta is opposite side divided by hypotenuse. That means the opposite side is x. The opposite side of the angle theta is x. So this is x and the hypotenuse is 5. Alright, if the hypotenuse is 5, the opposite side is x, what is the adjacent side? The adjacent side will be square root of 25 minus x squared. Well, I'm sure you have no problem following that. In a right triangle, we have 5 squared plus x squared equal to, suppose I call the adjacent side as y. So I have 5 squared plus x squared equal to y squared if the adjacent side is y. No? Is this right? No. It will be x squared plus y squared equal to 5 squared. Pythagorean theorem. The square of the sum of the squares of the two legs. X squared plus y squared equal to 5 squared. Not this. Alright, just delete that. And that will give, if you solve this, you will get y equal to square root of 25 minus x squared. And that is what is expected in here. That means when the opposite side is x, the hypotenuse is 5, the adjacent side is 25 minus x squared. So we can now use this to obtain these quantities in terms of x. What is cot theta equal to? Cot theta is adjacent side over the opposite side. Is that right? Yes. So cot theta is adjacent side divided by the opposite side, and that will be square root 25 minus x squared divided by x. That means this cot theta will now be replaced by square root 25 minus x squared divided by x, and that gives us our original integral quantity is this, equal to negative. Negative comes from here. Negative cot theta is square root 25 minus x squared over x, and of course multiply by 1 over 25, and this is our final result. And look how simple that integration was made as a result of this beautiful substitution. Okay, let's do another one. Evaluate the